Welcome back to Black Robot. In the last chapter, we covered arrays, strings, and pointers. That was all about handling memory and sequences. Now we are moving one step ahead into the structures and bit fields. So these are extremely important for embedded systems. Why? Because they let us model real-world type entities in code and even directly map software variables to hardware registers. That's powerful. By the end of this video, you will see how structures help us organize data and how bitfield help us control hardware at the bit level. Okay, so in that case, structure groups multiple types together. Why structure? Uh, because arrays are nice, but they have a big limitation. They can only store one type of data. Imagine you want to store information about a student, their name, such as string, their age, such as integer, and their marks, such as float. Can you do with this with an array? No. Array can only hold one type, either all integers, or all floats, or all characters. That's where structures comes in. A structure allows us to group different data types under one name. Okay. So structure groups multiple types together. So multiple types can be as a string, integer, or float. So, so in that case, think about think of a student ID card. Okay, it has a photo, a name, an age, and maybe a grade, character. Each field is different, but they are all stored together on one card. That's exactly what a structure does in C. So if you're seeing here an example, how it is defined with the structure, you need to define as a struct. Okay, and this defines a new data type called student. So it's a data type called as a student. Under that, if you're seeing here, multiple types of data types as a character, integer, and float is given there. So a character array for the name is given, an integer for the age, a float for the marks. Notice the keyword struct. It tells the compiler I'm creating a new structure. After defining it, we can declare variables of this type just like int or float. So how we can declare and access members? Uh, Once a structure is defined, we can create variables from it. If you're seeing here how we are calling student S1, okay. So here S1 is a student object. Okay, S1 is a student object. We use the dot operator to access its members. So S1 age means the age field of the S1. Okay. So it is accessing here age. So think about think of the dot like saying go inside the form and find this field. So S1 dot age, go inside S1 and fetch the age field. So what will print here? It will print 20. Okay. So coming to the more example here, if you are seeing here name Ravi, age is given as a 20 and marks is given as a 88.50. So this shows how structures can hold mixed data types together. Array can't do this. So array will have only one type of data structure. Okay. So this is how s dot name, s1 dot name, because you're calling from this one. Okay. So you have created a structure students. So s1 dot age, s1 dot marks. So s1 dot name will call to the Ravi, s1 dot age will call to 20, S1 dot mux will call to the 38.5. So array of structures. What is array of structures here? So if you're seeing here, just like we can have array of integers, we can have array of structures as well. So now class 0 is one student, class 1 is another, and so on. This is useful when you want to store a group of objects like 30 students in a class. Under that, you can have a classroom register. Each page is equal to one student. Uh, that is called a one structure. The register will would be equal to array of structure. Okay, so there you will be calling array of structures. What is nested structures? Structures can even contain other structures. So inside that, okay. So how will we define this one? If you're seeing here, you are creating this structure, struct date in day, month, year. So inside the student structure, one another structure you are creating. So here each student has a date of birth, which itself is a structure. So just like a student record form might have a date of birth section inside it and one form inside another form. Structures with functions. A structure can also be passed to functions. There are two ways, by value and by reference. So how by value and by reference? By value, a copy is sent to the function, the original doesn't change. By reference, we send the address using a pointer. The function can modify the original here. Okay. So in embedded systems, we often use pass by reference to save memory because copying large structures can be expensive. So that's why we go for the pass by reference. One more concept is there, pointer to structures. So how you define the pointers of strings? So here instead of s1 dot age, we use the v pointer p operator to age. So operator is used for arrow operator is used for structure pointers. Okay. So that's how you call the pointer to pointers to structure. So instead, think of it as saying, I don't have the student form directly. I only have the pointer to it, but I can still get to its field. So you're calling address here storing, and if it is, this operator is pointing to A, so it means this arrow operator will be accessing to the field of this structure. Type def with structures. Sometimes with writing struct student again and again is boring. So we use the type def to create a short name. Okay. So how you create a short name? Now you can just write point instead of the struct point. Okay. This is y- used heavily in embedded code to keep things short. So if you're seeing here point, it is calling to type def, you know, struct point. In place of the struct point, we are using that. So structure is like a form with multiple fields. Each field can be different text, numbers, and options, but all belong together under one entity. Okay, so this is real life analogy, just like a form of one student or one bank account. So there can be the multiple examples inside that. Okay, so it can be, any animal that is having four legs, a color, then how it is running. So these kind of structures you can make it. Okay. So now coming to the bit field section here. What is bit field? Normally an int takes 4 bytes. But what if I only need 1 byte because to store something, right? I don't want 4 bytes there to store the integer. Example, uh, is the light on or off? That's just 0 or 1. Why waste 4 bytes there? So it means bit fields let us allocate a specific number of bits to variables. This is super important in embedded systems where memory is limited. So it means it saves the memory into embedded systems. Okay. So how you define the bit fields? If you're seeing here, unsigned int is on, one is given there, unsigned int error is one is given there, unsigned int ready is one given there. Here each flag takes just 1 bit. And instead of three separate integers, it means 12 bytes. This uses only 3 bits. It means you are saving here memory. So what is Boolean flags there? So Boolean flags in 1 byte. Imagine we want 8 Boolean values. Normally 8 integers would be used 32 bytes. But with bit fields, 8 bits is just 1 byte. That's a huge saving, especially when your microcontroller only has 2 KB of RAM, right? So, so there is one bit field with example is given there. Now, ID can hold values 0 to 15, needs 4 bits. Type can hold values 0 to 3, needs 2 bits. Valid is just 1 bit. Value is just here, valid. Sorry, my word. Valid is just 1 bit. This is used a lot in network protocols and IoT sensor packets. Why? Because ID, if you need four bits here, okay, so it means it will go to this type for to 0 to 15 values, right? So type can hold values 0 to 3. This holds 0 to 3 value, and this holds 1 bit only. So you can use it into the network protocols or IoT sensor packets where you are using to save the memory into embedded systems. So register mapping, coming to the register mapping, how you map the register there. If you're saying struct port, you have defined it a structure as a port. Inside it, for pin 0, you have defined pin 1, pin 2, pin 3. So for each pin, you have given 1 bit, right? So this maps directly to GPIO pins in the microcontroller. Each bit is a 1 pin. Okay, each bit is a 1 pin. Set it to 1 pin high. Okay, 1 means high. It means on. 0 means low. It means off. So this is what how you define it. How you access the registers. So if you're seeing here, the address of a register is given there. So you have defined a struct port pointer. The struct port pointer is given there. So if you wanna, you know, point set the pin for pin high. So P as a array pointer pin 0 is equal to 1, you need to set it. So what we are doing here we are treating address 0x40021000 hardware register as a structure. This is how embedded system talks directly to hardware. Okay. So what is the advantage of bit fields? It's very memory efficient. It makes code easier to read. So there is no need of manual bit masking. Perfect for representing status, flags, and hardware registers. Okay. So what is the limitation of bit fields? Implementation is compiler dependent. Order of bits may change on different machines. Okay. So it depends upon the machines as well. So order may get changed on different machines. Not portable. Should be used only for the hardware specific code. So coming to the structures versus unions, what is the difference between these two? So structures, what is structures here? Every member has its own space. Unions, what is unions here? All members share the same space. It means same memory there. So it means the structure would be having different memory. Okay. But unions would be having only one memory. Whatever would be the high one. So that's the memory would share. Okay. So that's the difference between structures and unions there. So what is the practical use case of uh, so that's a practical embedded use case. You mean you can use it if you are going to use. So GPI register mapping, how do you do that? So in that case, Bitfields allow us to directly control GPI pins instead of writing messy code of like port, port is equal to or one right 60. Okay. So we can just write pin 0 is equal to 1 there. Okay. So this is much cleaner. So we can avoid this and we can write this using the GPI register mapping. Okay. So what is the status flag there? So microcontroller have status flags. Those are carry, zero, overflow flags. So using bit fields, we can store all of them in just one byte. So these three. So you can, explore more on other sources. What is basically the status flags? Basically, you have studied might be into the electronics as well. Okay, so how it goes. So coming to the config bits, configuration bits control settings like baud rate, mode selection. It means the communication mode. And third one is interrupt. So all of these can be mapped neatly with the bit fields. So what is the, coming to the best practice says, so use typedef to simply names. Okay, for readability. Use unsigned int for bit fields, no negative numbers. Okay, use unsigned always. Be careful with alignment and portability. Compilers may pad. Avoid bit fields for portable code across different systems. So this is what about the uh, registers and register GPI, registers mapping, structures and bit fields. If you are having any question, you can comment below into that. Okay, so so today what we have learned is structures. So structures is it groups multiple data types together. Bit fields, it works at the bit level, memory definition. Register mapping, it connects software with hardware. So these concepts are must known for any one writing embedded code. So you can go through it. So structures, help you organize data. Bit fields help you control hardware. Okay. So together they are the bridge between software and hardware in embedded systems. So in the next chapter, we will continue our journey deeper into the system level programming. Stay tuned. Thank you. Thank you, everyone.